Hi, I'm Richard Denton. Today I'm going to be continuing a series of 8 talks on science, Christian faith, and the days of creation, approaches to reconciliation. And today and in the next talk, I'm going to be talking about evidence, scientific evidence, and today about evidence for an ancient Earth. In the bottom left here, you see a picture of Marie Curie, who pioneered discoveries on radioactivity. And in the bottom right, you have Edwin Hubble, who examined the relationship between distance and velocity of galaxies. So there's a shift here that in this talk and the next one, I'm mostly going to be talking about scientific evidence. And so today I'm going to consider what is evidence for an ancient universe that might make you want to consider shifting to a progressive creationist view. In the next talk, I'll talk about evidence for evolution, which might cause you to consider an evolutionary creationism view. So, evidence for an ancient universe. Well, it turns out that the most distant galaxies are so far apart from us that the light has needed billions of years to get to us. Edwin Hubble studied the relationship between the distance to galaxies and the velocity at which those galaxies were moving away from us. And this shows that there was roughly a linear relationship. And so the farther away galaxies are moving farther at a faster speed away from us. And by taking these galaxies, the distance, and dividing by the velocity, you can get an estimate of the time that they have been proceeding away from us, and it's about 14 years. So this is similar to if you know that that it's 60 miles to the nearest city, and you know that your speed was 60 miles per hour, then you can divide 60 miles by 60 miles per hour and find out that, well, you left an hour ago. It's basically as simple as that. Another estimate of the age of the universe comes from stellar evolution. And it turns out that based on very precise models of how stars evolve, we can show that the oldest stars are between 10 and 15 billion years old. Now, at the farthest distances, the young stars consist of just hydrogen and helium. But closer to us, we see stars with heavier elements. And this is consistent with the way that heavy elements are built up in stars. First, there's a stage in which helium is combined into carbon. And then there are also supernova explosions, which create even heavier elements. Another estimate of the age of stars comes from white dwarf stars. These are have very special properties, and it can be shown that those stars are between 12 and 13 billion years old. So these stars, these oldest stars and these white dwarf stars have to be older than the age of the universe. And so it's pointing to something about 14 billion years. Another estimate for the age of the universe comes from radioactivity. So the idea in radioactivity is that you have an unstable element. These are most commonly heavy elements, and they decay away, or they break up or decay away into smaller atoms. And the half-life is defined so that if you start out with a certain number of what we call the parent atoms, the heavy atoms, After one half-life, you have half of those, so you go from 100 to 50. And then after another half-life, after two half-lives, you go down to half of 50 or 25. And so it keeps cutting by half every time you go a half-life. And so from the ratio of the daughter, the product of the reaction, to parent atoms, you can see how many half-lives you've waited. So if you have an equal number, you must have gone one half-life. So based on the radioactive elements created in supernova explosions, we get a rough estimate of the age of these explosions as 10 to 20 billion years old, based on the parent to daughter ratio. The age of the sun is estimated to be 4.6 billion years based on stellar evolution models. And this is consistent with the oldest radiometric dating ages of rocks in the solar system at 4.5 to 4.6 billion years. So you see, our sun is not as old as the universe. It's more like 4.5 billion years old. This shows some dates that were found from rocks that were submitted by young Earth creationists to a lab for dating. And what they found is for these rocks, using 4 different radiometric techniques, they found the dates shown here. Now, these were from the Grand Canyon. So on a linear scale, it looks like this. And so this shows billions of years. And then here are the dates from the 4 different techniques. These are the error bars for these techniques that were estimated. This one appears to be significantly lower. The reason it has a gray dot instead of a red dot is because this technique is known to be susceptible to errors due to leakage of some of the daughter nuclei. And so it's not considered as reliable as the other techniques. The other techniques are relatively more consistent. This one, the error bars are outside of the range, but the error bars don't mean necessarily that you have to be in that range for them to be consistent, but it would be improbable that for this measurement with these error bars, so probably the errors are underestimated for this measurement. Now, if you look at these dates, you might say, hey, this one is 500 million years different from this one. So these dates, you might think these dates are not consistent. Well, one factor is what I already said, that this technique is not as reliable. But another thing to keep in mind is that this technique is based on, it predicts a number of half-lives. And so a more accurate way of representing these numbers relative to each other is with what we call a log scale. So on a log scale, you see a factor of 10 from 1 billion to 100 million, 1 billion to 100 million as one division. And then when you go a factor of 10 less to 10 million, you go the same distance on this log scale. And if you plot it on a log scale, you see that these numbers are pretty consistent. And the point is that 500 million might seem incredibly different from 1.2 billion, but in terms of the number of half-lives, it's not that much different. So these don't look that different. So these dates are pretty consistent based on the way we measure dates from radioactivity. Another way, another thing that shows us the dates is the forms of life that we see in the geological record. And if you line up the types of fossils, they tend to be the ancient fossils with older dates appear to be at lower levels in the geological record. And as you move up, you go to more and more modern types of fossils. Now, this has been criticized by young Earth creationists that, oh, this is circular reasoning. People use these fossils to find the dates. But the order of the fossils was determined by observation before any dates were known, before there were studies about specific dates. So the fact that these fossils line up in these fairly regular patterns shows consistency with the dates and is a reasonable way to date rocks. Based on this, the geological ages are based on these types of life, the ancient life and middle life and modern life. And so now we have dates in millions of years based on these geological levels. Now, one of the things we see happening is the movement of the geological plates. So over here we have the African plate, and that is moving away from the North American plate. And what's happening is that there is material coming up in between these two plates, because if you separate these plates, then there's like a hole in between. So what happens? Well, lava keeps bubbling up in the middle. And this is a picture of the lava coming up in the middle of the Atlantic Ridge. Now, if we take the dates of the rocks close to the end of these plates, we find that the rocks on the African side and on the North American side are about 180 million years old at the edges of these continents. And if you divide the distance between the coast of Africa and the coast of North America, and you divide it by this time, it gives you a speed that these plates might be receding from each other of about 1.1 to 1.7 inches per year. So that's a pretty small rate based on this large amount of time. Now, the really fascinating thing is that with modern technology and global positioning, we can use satellites to measure the rate that Africa is receding from North America right now. And what we do using this is we get a rate of about 1 inch per year. So what this shows is that the dates from the radiometric dating are consistent with the actual rate of change that we observe now, the actual speed of recession of these continents that we see now. Before I leave the topic of dates of the universe and the Earth, I'd like to mention that tree rings have been dated to 14,000 years. Now, this isn't done with a single tree because there's no one tree that has been alive for that period of time. But what you can do is take different tree rings from different samples of wood. So here you see, here we have a modern tree that has tree rings. and here's maybe a log that came out of a log cabin, and then here there's some more ancient tree that was found under the ground. And you can match up the tree rings for the first one with the second one, and the second one with the third one. So that's the basic idea of this technique. Now, the reason I mention this is because many young Earth creationists believe that the age of the Earth is only about 7,000 years old. So we actually see trees that are older than that. And lake sediment layers with a similar technique where you can see yearly deposition of layers have been dated to 50,000 years. And these dates are consistent with carbon dating. So my conclusion about this is you can be a Christian and be a young Earth creationist, a progressive creationist, or an evolutionary creationist. There are good Christians with all of these different kinds of beliefs. But there is a large amount of consistent evidence that the Earth is about 4.6 billion years old. This conclusion is not a humanist conspiracy. Before I leave this, I'd like to make one more point, because I keep running into this idea. People will say, well, what if God created the world recently with an appearance of age? In other words, he created the Earth with all these fossils, for instance. This is possible, but is it likely? So in considering explanations in science, we consider a principle called Occam's razor, and it suggests that usually the simplest explanation is most likely. So, for instance, how do I know that I wasn't just created just now? How do I know that my memories are real? How do I know that my wife is real? Well, I don't know for sure. It's possible that I was created just now with those memories, but most of us don't believe that. And in the same way, it's far simpler to say that those fossils under the ground are from real living creatures that lived at one time, than that they were planted there. Psalms 19 says, "The heavens declare the glory of God. The skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they reveal knowledge." What does this mean if the things that we see taking place in the heavens, like supernova explosions, never happened? They were just put in the record of the light that's coming to us. What does that tell us? What do the heavens mean in that case? It means that the heavens are deceptive. So what would it say about the character of God if he planted for evidence for things that never happened? So this is why I don't think that argument is really very good. Well, thank you for listening today.